All right, everybody. So this is the last video for this segment. I know it's been very long. Honestly, I find it strange that we're covering horizontal and vertical stretches because it is a type of dilation, but it's not a type of dilation that you normally see. In fact, um, if you do a horizontal and a vertical stretch, it's basically dilation. Just horizontal just means you're making something bigger from left to right. So let me grab my pen out real quick. Sorry, guys, I signed it to the wrong one. Force a habit. Okay, so you can kind of get an idea of what a horizontal stretch is by the picture that you see right here with this rubber band. But the main idea between horizontal and vertical stretches, like I said, this usually is a topic covered in geometry. I think Edmentum just really wants to get into the details of it. So if we're doing a horizontal stretch, let's say we have this triangle and we wanted to do a horizontal stretch. What would happen is the height of the triangle would stay the same, but the horizontal part of it would change. Now, the reason why this isn't a dilation is because we learned before that dilation means that the angles stay the same. Well, if this is getting bigger, this angle also gets bigger. So that's how come this isn't necessarily a dilation. Same thing could be true if, let's say, we wanted to do a vertical stretch. What'll happen is only the height would change. Well, now because the height changed, this angle got way smaller. So this isn't necessarily dilation. That's why they focus on calling it a stretch. So I think the reason why we're going to do this next activity is because they really want to distinguish that only stretching out on the horizontal or only stretching out on the vertical is not considered a dilation. It seems like a dilation because we are increasing and decreasing, but as we'll see right now in this activity, it's not necessarily true. So what I'm going to do here is we're going to go to our horizontal and vertical stretches. And I am only going to do a horizontal stretch here. So I'm going to stretch it like twice. So as you can see here, it's only increasing the stretch. It's increasing the distance from the y-axis, basically. So if I change this to 2, what I'm going to do for this activity is here, I'm going to change this to 2. And then for A prime is a point. So this point should be right here. So I'm going to stretch this out a little bit. So it becomes 4, 1. As you can see, we're only doubling the x value. So because we're only doubling the x value, if I put like h3 here, for example, so if I change this to 3, I'm only going to triple the x value. So this becomes 6, comma 1. And you can guess what happens if I double this one. So I'm going to double the b value for this one. So I'm saying I'm going to double this. So this becomes 8, comma 2. And we can verify that by checking our GeoGebra. So if I go to b prime, that's 8, comma 2. And this one should be, if I triple it, it should be 4 times 3 is 12. So it should be 12, comma 2. And I can verify that by, I'm going to move this to 3. And I'm looking at the A prime, that should be 6, comma 1, just like I guessed. Oh, I guess I didn't really guess, I calculated it. And 12, comma 2, that should be what I put down here, 12, comma 2. So as you can kind of educatedly guess from that, what we're going to do is we're going to double the x value from here. So that becomes 10, comma 1. We're going to triple the x value here, so that becomes 15, comma 1. And that's all we're doing for this exercise. Whatever number we're doing, we're going to multiply that here. So basically what's happening is it becomes nx times whatever our original x is, comma y. So we're leaving these y's the same. So all of the y's are going to be the same for the horizontal stretch. Now that being said, when we're doing our vertical stretch, what I'm going to do is when you're doing this exercise, you want to make sure you put your horizontal stretch back at 1, and then you're going to do this. So what's happening here is the distance from the x-axis is starting to increase. So that's what's known as a horizontal stretch. So basically, if I were to make both of these numbers match up, go to 3, go to 3. Oh, it's not doing for both of them. But if I were to combine both of these, that would make a dilation. It would essentially increase the distance diagonally that way, instead of increasing it for horizontal, increasing it this way, and for the vertical, or increasing it this way for the horizontal. It kind of combines these two, making kind of this little triangle. So that's why I said that vertical and horizontal ones are combined make a dilation. So here, whatever we're multiplying, we're only going to change the y values. So if I put a 2 here, it's going to be 2 comma 2. I'm only multiplying that. If I put even if I put like a 5 here, it should be 2 because it stays the same. This x value stays the same. And then 2 times 1, or I'm sorry, 5 times 1 is 5. So that's all we're doing for this one. We're simply just multiplying this y value. So moving on, what do we notice for the horizontal stretch? It's like, oh, all we're going to say is we multiply the x value by the horizontal stretch factor. And we also have to answer it for the vertical. What do you notice about the x coordinates? Or what do we notice about the y coordinates for that? Oh, they're actually asking me the opposite. Weird how they do this. So when we do horizontal stretch, the y values stay the same. And I had already explained that when I was first talking about this. What do you notice about the x values when we do vertical stretch? When we do vertical stretch, the x values stay the same. So it's basically the opposite. They're asking you about the opposite thing. They're asking about y values when we're doing a horizontal stretch. Well, nothing's going to happen. They're asking about x values when we're doing a vertical stretch. Again, nothing's going to happen. In question 1, what do you notice about the x values on the horizontal stretch? So this is a question I was actually answering when I first started typing out for question 2. But what we're going to say here is the x values. I'm saying x values. I know they use the word x coordinate, but I'm just talking about the number. The x values get multiplied by nx. And if you want to write it the way they do, I recommend using the equation editor. We're going to write n. We're going to use a subscript. So this is a subscript. This is known as a superscript. X. We multiply it by nx. When we do a horizontal stretch. What's happening here basically is what we're saying is NX is the horizontal stretch factor. So that's one thing we can mention. You can decide not to mention. I think it's kind of implied. NX is the horizontal horizontal stretch factor. So just like we had a dilation factor, this is going to be our horizontal stretch factor. All right. So the next thing we're going to do is we're going to talk about the vertical stretch. So when we do this, so we multiply the y coordinates. I'm just going to kind of put some diversity in here. That should be a y, not a v. Y coordinates by my equation editor and subscript y. This just lets me know that n is that number that I'm multiplying, but I'm only multiplying it by the y values. So I'm multiplying the y coordinates by ny when we do a vertical stretch. All right. And the last one, move the horizontal stretch factors in there, move the select, observe what happens to the interior angles of the triangle. So I already kind of talked about this, but let me show you how you do it on GeoGebra. I'm mainly going to talk about this angle B like I did before, but let me start measuring this angle. So I'm going to go counterclockwise. So if I want angle B, that is not how I do it. Counterclockwise. So I want to go from, wait, why is this thing's being difficult, guys? I'm sorry. I want to go counterclockwise. So from here, is it not going counterclockwise now? Now it's going clockwise? I don't know why it doesn't want to measure my angle. There we go. Oh, counterclockwise. And then if I want to go counterclockwise, I want to go this way. And again, I want to go counterclockwise, so I want to go this way, counterclockwise. So I want to go from here to here. And I'm going to measure it compared to this one. So as we see here, I'm just going to compare the one angle for now. Let me delete this one because I mainly want to compare it to B. So if I want to compare it to B, I don't know why it's not working, guys. I'm sorry. There we go. If we compare it to B, notice how it starts getting bigger and bigger, or smaller and smaller and smaller. I had this kind of like hidden, so I didn't see that it was like 108. So we see that it keeps getting smaller and smaller and smaller the bigger it gets. Here, what we would see is if I measured it counterclockwise. So if I measured this when I'm doing the horizontal stretch, this keeps getting bigger and bigger and bigger. So it depends what angles we're talking about. If you look at the angle C, what's happening is it keeps getting bigger and bigger because this keeps stretching out. So that's what we're just going to talk about. So the main thing you want to just talk about is angles change because the points on the shape are not proportional. So this, you guys can use a different word for this. This is like the correct way to say it. But what you would say is the angles change, and if you want to use like simpler words instead of using this, you would say because the sizes don't change equally. And let's say sides. The sides don't change equally. So obviously, if you're changing it horizontal, only the horizontal parts are going to get bigger. The vertical ones don't change the same. So that's what I mean by they're not proportional. They're not changing equally, is basically what I'm saying. And as always, guys, let me know if you're having trouble with this. If you are, schedule an appointment. I can explain it more. I know these videos are long. I wasn't expecting it to take this long. I think I took too much time and detail on it. But here we can see what they're talking about. So if we're doing a vertical stretch, we're only going to multiply the y here. The x stays the same. That's all it's saying here. And here, okay, so so these are our corners. And we're going to do a horizontal stretch factor. So we're stretching it by 3. What is the area of the image produced? Okay, so unfortunately, this one is a tough one, guys. So we're going to have to, I recommend using something like GeoGebra to keep track of it. So you can go to geogebra.com, or you can even just Google like a random sheet. What I'm going to do is I'm going to use a website called Desmos. If you guys have taken like an algebra class or come to me for tutoring, you probably are aware of Desmos. I use this a lot. So what I'm going to do here is I'm going to copy this point, copy these points. Hopefully Desmos can convert it. I'm going to have to delete that and. I know for a fact Desmos will not copy that. So here's my rectangle. So I just got rid of that and now I can see my rectangle. I'm going to do the little quick change here so I can see it individually. Changing these things called steps let me see the numbers better. So what I can see here is from here to here, this is 2. And from here to here, this is 1, 2, 3. So my area, if I'm doing length times width, is, and I can't even count them because I'm using a graphing tool, is 6. This is a 1 by 1, 1 by 1, 1 by 1, 1. So I have a 6 unit squared thing. By unit, I'm just saying whatever these are. They're 6 units squared. They're 6 square units. But they want to do a horizontal factor of 3. So in other words, I'm going to multiply this by 3. So this becomes 6. So now I'm going to have a 6. That's 1, 2, 3, 4, 5, 6 by 3. So if I have a 6 by 3 rectangle, I'm going to end up having 18 of these squares. So 16 times 3 is 18. So my answer after I stretch it is going to be 18. All right. And then, as always, guys, study your transformations, understand what a translation is, what a reflection is, what a rotation is, dilation, and the difference between stretch and dilation. That's like a tough one to kind of understand. Dilation is when you do a horizontal and a vertical stretch, whereas horizontal and vertical, you're only changing one of them. So again, as I promised, this was a short video. I'm sorry it had to come out in 3 videos, guys. I'll try to compact this and be a little more concise next time.